Hello, everyone. Welcome back to another episode of the webinar series we're hosting at Ethereum Greece, where we invite engineers, researchers, and builders that are actively building on Web3. Together with us, we have Diana Kocsis, protocol engineer at Uniswap Labs. I'm very glad about this one. Uniswap was one of my favorite protocols, to be honest, and it was the protocol I started playing from the beginning. I was an early adopter, and it led me all the way to working with AMMs through my PhD. So I'm very happy about this one. Diana, the stage is yours.
All right. Thanks for having me. I'm Diana. I'm a protocol engineer at Uniswap Labs based in New York City, and I helped build V4, the exact code that we're going to be looking at today. So I'm hoping you'll leave this talk knowing why V4 exists, what hooks make possible, and then we'll have time at the end too for some questions. So here's the agenda for today. First, we'll be talking about the road to V4, like where AMMs came from. 2, the architecture of V4. 3, the heart of the talk, which is hooks. And then 4, what it actually takes to ship a hook to mainnet. So let's start at the very beginning. So an exchange is just a place where buyers meet sellers. So traditionally, that's an order book, a big list of standing buy and sell offers. And most of those offers come from a handful of professional firms reposting their quotes thousands of times a minute to track the price. But on a blockchain, that job gets even more expensive, as you can imagine. Every single quote update is a transaction. So DeFi asked a strange question, what if we replaced that whole job with a formula? And that's the AMM answer. So the AMM answer has 3 parts to it. There's a pool, which is reserve of 2 tokens deposited by anyone. We call them liquidity providers, or LPs. A formula that it quotes every trade deterministically from those reserves. So there's no orders, no downtime, no matching or anything. And a fee also on every swap, which pays the liquidity providers for the risk that they're taking on every swap. So the key insight here is basically that nobody sets the price. The price is implied by the ratio of those 2 token reserves. And then arbitrageurs come in and they keep it in line, the price, with the rest of the world. So that formula sits in this magic formula called X times Y equals K. And this is what Uniswap V2 was all about in May 2020, where it was launched. So basically, if you walk the curve, you push token X in, and then you slide along the curve, and then you pull the token Y out. And bigger trades bend you further along the curve. So that's slippage or price impact. And V2 had a flat fee of 0.30%, and that went to LPs on every swap. And Uniswap V2 was a revolution. Basically, any 2 tokens listed by anyone, 1 transaction. There's no committees, no listing fees. And it worked so well that everyone copied it. So V2 alone, Uniswap V2 alone had $60 billion of trading volume in its first year. And it didn't just attract traders. Like I said, it also attracted people who wanted to fork it and copy it and make some features of their own that were a little bit different from it. So every project on this slide that you see is a fork of the V2 code base. But forks cut both ways. They innovate, like I said, so real features come out of forks, but also a fork changes audited and trusted code. So one example is Uranium Finance forked V2, and I think they updated one constant in two places, but not another one. And then that one slip cost them $50 million. So people clearly want to modify Uniswap, but forking is just, it's a pretty dangerous way to do it, just because Uniswap and this code is very heavily audited with lots of reviews on it. Also, another thing, V2 had a pretty big flaw, which was capital inefficiency. So V2 spreads liquidity across every price range from 0 to infinity. And there's capital in the pool just sitting there then, just in case ETH goes to $1 or to 1 million, just in case. So liquidity is sitting everywhere in the whole price range. So as much as I would love ETH to go to $1 million, it's pretty unlikely. So it's very capital inefficient. So you can kind of think of it like a shop who are keeping their shelves stocked for customers who will literally never come. It's just there, but it's never going to be used. So almost all trading happens near the current, around the current price where you can expect it to go. And then most of the pool's capital is just never touched. Well, Uniswap V3's answer was let LPs choose where their capital lives. So in comes concentrated liquidity, May 2021. So here an LP picks a price range, and their capital only trades and only earns inside that specific range. So everyone stacks around the current price or where they expect it to go, and the capital makes dramatically deeper markets. So by August 2021, V3 was doing about 3 times V2's volume with half the capital. And V3 also introduced fee tiers. So now there's 4 fee tiers. Well, it actually started with 0.05, 0.30, 0.05, 0.3, and 1%. And then 0.01% was added later by a governance vote that we had. And the 0.01% was great for stablecoin specifically. So that was a really good thing. But concentrated liquidity, as everything else, it comes with a trade-off. So it's great for swappers, but it's genuinely harder for passive LPers who just want to sit and park and forget about their liquidity. Because if you put your liquidity in a certain range, forget about it, and then price goes up or price goes down, then you're not earning any fees anymore. So every feature on V3 is basically an opinion. There's oracles on V3, the different fee tiers, they're all features in a way. They're all opinions. And none of these are wrong, but they're also Uniswap's opinions. They're hard coded into these immutable contracts for everyone to use. So that kind of raised the whole question about V4, where what if the community could make the design decisions without forking the protocol? And that's why the AMM design space is now just so enormous. And that's exactly what V4 is. So before we get into V4 now, are there any questions? I'll stop for a little bit. Any questions so far on what I covered? If not, we could also wait until the end too.
Guys, any question? No. Okay, I think Diana, you can move on.
Okay, sounds good. So V4 went live in January 2025. I can't believe it's been that long ago, actually. But the code was open sourced in June 2023 and designed in public for a year and a half. So I've actually started working at Uniswap February 2024. So when I started, I like got straight on V4, but they were actually already working on it before I got there. So it was actually really cool to like start at Uniswap and then start right away working on something so cool. But yes, so V4 though also wasn't just created by Uniswap. There were over like 60 outside contributors too who like merged code and you know, made a commit, participated in it. People found bugs, like people put in gas optimizations and proposed features that like ended up actually being shipped. So it was like a huge community effort. And actually, if you see here, March 2024, the protocol literally waited for an Ethereum upgrade, which included transient storage. So, and that made its architecture very cheap, which we'll get into shortly. And then there were also like 9 independent audits, which is crazy. $2.35 million security competition and $15.5 million bug bounty. So huge effort. And what did all of that produce? Well, V4, I'd say, is like, it's not V3 with more features. It's a platform, you can think of it as. And it's a platform where you can build your own AMM on top of this shared, very much audited, battle-tested infrastructure. So it's like you can fork it, but it's like less of a risk now. Or it's not, you can't really fork it, but you could like add your features now on top of it without the risk of forking it, basically. And then there's 2 big architecture changes, and then we're also going to get into the hooks part as well, where you can, and the hooks is the part where you get to plug in your own code into the pool. So change number 1 is the singleton contract. So in V2 and V3, every pool is its own deployed separate contract. So creating a pool means deploying like new code, whole new contract, and then multi-hop trades. If you think about it, they physically move tokens between contracts. So if you want to go from like USDC to ETH, but then like if you want to first like transfer USDC to DAI and then like DAI to ETH, it literally has to go through 2 different contracts. But now with V4 in singleton, every pool like lives inside that one contract, which is called the pool manager. So there's two consequences. Pool creation gets cheaper, 99% cheaper, in fact. And then multi-hop swaps never move tokens between like 2 different contracts. So it's just a very cheap way now to move value around. And then you can kind of think of change number 2, which is flash accounting. You can think of this in a way sort of like a bar tab. So let's say like you unlock the pool manager, meaning you've opened a tab. And then you can do like any number of actions across any pools. So you could like swap, liquidity changes, whatever you want. And then the manager, the pool manager, it doesn't move a single token. It just like tracks the balances, the net balances. And these net balances, we call them deltas. And then when you're done doing whatever you wanted to do on the pool manager, you settle the tab to 0. And then you lock the pool manager back up. And if you like can't settle at the very end, the whole entire transaction reverts because it's atomic. So let me show you an actual example. So if we walk the table row by row, this is swapping ETH for USDC. So you're paying WETH and you want USDC. So the tab reads like -1 WETH because that's what you're going to owe, and then plus 1,800 USDC because that's what you could take. So swap that USDC for DAI then, and now your DAI is the plus and the USDC is back to 0. Okay, so then you're going to take the DAI out and you make that 0, and then you settle the WETH by sending the WETH in, and that becomes 0, and then lock all zeros, transaction valid. So if you look here at USDC where it says plus 1,800 and then it went back to 0, that token like physically never moved. So only 2 real transfers happened in the whole trade, and that happened from the take and the settle at the end. And then that's where that multi-hop gas savings that I mentioned comes from. And this one EVM feature that makes all of this very efficient is the transient storage, which is EIP 1153. And that storage that exists only for the duration of that one transaction, and then it vanishes. So the deltas have to hit 0 by the end anyway, like we mentioned. So like, why pay for permanent storage? Why in that one transaction, like keep on updating the deltas in permanent storage when like, you know, they're gonna like constantly change and at 0 at the end. So that could just be like all cheaper. Let's wait for this transient storage. And so it's like much cheaper and much cleaner code. And another thing that V4 changed, well, like we mentioned before, V2 had like the 1 fee tier, and then V3 had 4 fee tiers. Well, now like V4, it stopped being like a specific selection of fees that you could choose from. And now you could choose any static fee from like 0 to 100%. You're actually also even allowed a dynamic fee, which is super cool. And that's controlled by the pool's hook. So that brings us then now to hooks. So again, any questions here before I move on to hooks? Okay, let's keep going then. So a hook is a smart contract attached to a pool at the pool's creation. And the pool manager calls it at specific points in like the pool's life cycle whenever someone wants to interact with that pool. And there's 4 actions. So it's initialize, swap, modify liquidity, and donate, each with a before and an after callback. So it's like before initialize, the hook can like perform some actions, and then after initialize, the hook can perform some actions, and then so on. And notice also that add and remove liquidity are split into separate hooks. So it's not just before modify liquidity, after modify liquidity. They're split into like 4. Before add, after add, before remove, after remove. And this is like very much done so on purpose, because if you think about it, like add and remove are really different, because remove can obviously be very dangerous. Like imagine a hook that has before remove liquidity flag on it, where it just like reverts every time, and then users' liquidity can just get stuck and users won't be able to withdraw their liquidity. So we really wanted to like separate out these permissions just to like make it clearer for users who could be interacting with pools with a before or after remove liquidity hook. Yes, and there's also 4 like special return delta permissions too. that let a hook change the amounts. So those are also like, they also could potentially be scary to use as well. So you really need to like trust hooks that use like these permissions. And where do the permissions of a hook live? Well, they actually live in the hook's deployment address in the last 14 bits, the least significant 14 bits. So fun fact actually also is that the flags originally lived at the top of the address in the beginning of V4 development. But then we actually decided to move them to the end so that like hook deployers can like mine vanity address with like leading zeros at the beginning of an address and save some gas too. So like basically each hook permission is its own bit. So like if one is on in this spot, then that means the before swap permission is on and that hook callback will be called. And hooks can do like so many things, like dynamic fee swaps, like we mentioned, like LVR, mitigation, price oracles, loads of stuff. So let's get into an example. We can start with a dynamic fee hook. So there's two ways a pool can have a dynamic fee. One is the hook directly calls update dynamic LP fee on the pool whenever it likes, and that changes the stored fee. Or two, directly in the before swap callback, which returns a fee with an override flag, and that prices one single swap. So like a single swap can carry its own fee. And that's what's really cool about like the dynamic fee space in general, is that like like a fee can change on every single swap depending on like what kind of swap it is. And to like find whatever swap fee, like a swap used, that's directly in the swap event, and that would be like the source of truth. Because if it's dynamic, that pool key, because a pool key is dependent on like 5 things: the 2 token addresses, tick spacing, fee, and the hook address. And that fee, if it's dynamic, it's just going to say dynamic fee. So it's not going to like update every single swap, like what that fee is. So the way to like find out what fee was used on a specific swap is through the event. And this is for dynamic fees. But if you want to actually like change the amounts themselves, that would be through something we call custom accounting. So this is when like a hook actually like takes something. And that's coming from like the return delta permissions that we have. And basically when a hook returns like these return deltas permissions, the pool manager will reshape how it's working. So there's actually one vocabulary lesson I want to go over first because it's pretty confusing and it's a big change that we made from V3. So there's 2 kinds of swaps, depending on which number the user fixes. So say like I'm paying exactly 1 ETH, give me whatever DAI that's worth. That's exact input because I'm specifying I'm sending in 1 ETH no matter what. Versus I want exactly 2,000 DAI, take whatever ETH it costs. Like I want 2,000 DAI no matter what, like take whatever you want from my wallet. And that's exact output. And then also the token whose amount the user fixed is considered the specified token. So the other one, the amount the swap math has to figure out is called unspecified. So amount specified is negative when you fixed what you're paying in, and then positive when you fixed what you're getting out. And that's kind of different because I'm pretty sure in V3, if it was negative, that meant what you were receiving, not what you were sending it. So V4 kind of changed it to make it like based on the user's perspective. So if it's negative, that means like negative, I'm losing it from my own wallet, like user's perspective. And then positive, I'm able to take it. So it's a little bit different. It's confusing. Yeah, so a little bit confusing terminology. But the hook deltas that I mentioned are expressed against like the specified and the unspecified roles that I mentioned. So we can work through an example of a hook that, like, say, takes a 1% fee on input. So the user swaps, say, like 100 uni exact in. So amount specified is minus 100, like we talked about, always in perspective of the user. And then in before swap, the hook computes the fee. So it wants to take 1 uni, like 1%, on this specific swap. So it takes it from the pool manager. And then it returns a before swap delta of +1 on the specified side. And then the manager updates the math. And now it's like minus 100 plus 1. And so the core is now swapping 99 because the hook took the 1% fee. So now instead of like swapping 100 and me getting whatever I wanted out, now the pool manager is going to be swapping 99. So I'm going to get a little bit less out because of that hook fee. And then like that take created the debt, the return delta assigned that debt to the swapper, and then at settlement, the user still paid 100, but the pool received 99. The hook holds 1, and then every delta at the end is 0. And if like for some reason the hook takes without returning or returns like without taking, the tab like can't settle. And then the whole swap will revert, like we talked about. It's all atomic. If the deltas aren't cleared at the end, it reverts. So that was a fee on the input. But then like there's also after swap where you could take a fee on the output. So on like a normal exact input swap, the output doesn't exist yet. Because like it didn't go through the swap yet. It was before the swap. So the swap math hasn't run yet. So the fee waits for after swap, which receives the result, takes its cut, and then returns the delta. And you can think of it like if the amount is known before the swap, take it in before swap. If it only exists after, take it in after swap. And but that's like a special case. But also something interesting is before swap would be exactly also how like custom curves work. And custom curves are pretty fun. So custom curve is like full replacement of the V4 concentrated liquidity swap math. So it could all run in before swap where it can return minus amount specified. So like the complete opposite of what you specified. And we call that like a no op because it's 0. And then like 2, it takes the full user's input in the hook, runs its own math, and then literally can like run it on any curve that you want. And then 3, it like still needs to settle the output back, and then it returns it as the unspecified delta. So that's the whole pattern. Yeah, but you still need to inherit everything. Like you still need the pool manager and everything, but it's just avoiding that swap math. So it's very powerful. And obviously like very easy to get wrong and hurt yourself. But it is an interesting use case. Yeah, and I also wanted to talk about this one error too, the hook delta exceeds swap amount. This like 9 times out of 10 is like if you're getting the exact input hit with like an exact output swap. So it's kind of if you're getting those amounts that I said were tricky wrong, whether it was like exact in or exact out, and whether to make it negative or positive. So I would take a look at that, because it is different from V3 and it can get confusing. But honestly, like the bugs that don't revert are like even scarier, because it lots of times like hooks like aren't going to catch, like if you do the custom accounting yourself in the different hook, or like the different swap math yourself, it can get confusing because it might not catch the math. Like the deltas need to end clear on pool manager, but still just like the error space does increase. Yeah. So let's keep it going. But basically, when you attach a hook, your code becomes part of the pool, like we mentioned, and permanent. The hook address is baked into the pool's identity. That becomes part of the pool key. And there's no upgrades, or I mean, it could be an upgradable hook, but I don't recommend doing that. And then there's no like hot fixes too, because everything that you put on chain is permanent and immutable. So if you want to like ship a new fix, it would mean like creating a new pool and then migrating liquidity over to the new pool. And then, yeah, if you're thinking about launching your own hook, just like test, fuzz, invariant tests, formal verification, maybe, independent audit. There's also like bug bounties, monitoring that you can do afterwards. Also, AI auditors are becoming like a lot better. So at Uniswap, we've been starting to use them a lot as well, in addition to an audit. So it's just like really great to like make sure your code is safe before launching 100%. And then there's also resources. Go to the V4 docs, go to core and periphery repos that we have out there. Base hook lives inside the V4 hooks repo. We have a V4 hooks repo now, which comes with like a bunch of tests, and like you can like make sure that you follow like the different standards. I would use AI to like, as much as you can, try to like follow along with our style and like our base contracts that we have out there. And yeah, if you want, like practice writing some hooks and like that before swap hook that we talked about where it takes a fee. But yeah, V2 proved that like anyone can make a market, and then V3 made it capital efficient. But now V4, it's up to you. Design space is endless. So yeah, go build. It's exciting. Any questions? Thanks, guys.
First of all, thank you for the great presentation. I really like the fact that V3 features are basically opinions, and I really like this analogy and how it fosters the creation of V4 and the design space it opens. I have some questions on my own, but first, let's hear from the rest. Guys? Okay, I've read it. Stefano says that, Diana, thank you. You answered most of my questions. He has one more. Is Uniswap V4 a good home for prediction market style tokens, ones whose price jumps sharply around a single event, or would you point that kind of asset somewhere else?
Oh, that is a good question. I think it's a really big design space currently about how to use Uniswap V4 for prediction market style tokens. I think it's definitely possible. I don't know, like specifically, I haven't started working on it, but it is interesting because if like you think about it, at the end of a prediction market, one token like goes all the way like to 100 and the other one is 0. And so obviously there's going to be impermanent loss. I think there's definitely a way, but I haven't been working on it yet. But I think it is there, and I think it is possible, but it is tricky. But I don't have an answer yet, but I know a lot of people are working on this, and it is out there. I think like Paradigm did like the Polymarket AMM challenge or something, I'm pretty sure. But I do know it's like a really big design space that people are working on. So I definitely do think it is possible.
Thank you, Diana. George? Did George just disappear? Okay, anyway, we go to Nikos. Nikos says, hello, thank you for the great talk. Can you share how Uniswap make its design decisions when developing a new protocol?
Ooh, good question. It's a lot of effort, I would say. Like a lot of design documents. We have our protocols team has actually like really grown recently. When I first started, I think it was like 5, which was like almost 2.5 years ago. But now I think we're like at least 15, which is crazy. But we have like protocols huddles at least once a week. And then we also have like smaller little pods too. And it's really nice because we like create design documents and then we share them with the team, and like people read the document before the meeting, share their thoughts on it. And then it's like a really good discussion that we have in our huddle, which is really nice. And it's honestly just like a lot of like bouncing ideas back and forth. And V4 took like a really long time to develop. I think it took, I forget what I said, but like at least 2 years, 3 years maybe, which was just really long. But I do think that like with AI now, things are becoming a lot faster and we're shipping a lot faster, which is really exciting. But yeah, I think it's just a lot of bouncing ideas off of one another and just like trying to like ship faster now because we can with AI. I think before the process was a lot slower because obviously we don't want any bugs in it. But I think now with AI tooling, like we're really like AI forward at Uniswap. And I think it allows us to ship things faster, which is really cool.
Okay, we have Dimitrios, go ahead.
Hello, can you hear me?
Yes.
Yes, thank you, Diana, for the nice presentation. I would like to ask that currently a lot of tokenized stocks are going on chain. Robinhood some days ago, Ondo, Backed, and etc. So I'm trying to figure out if V4 is the right pool architecture. So we need to enforce, let's say, some access control, some KYC, and things like that. So maybe trading our enforcement. Is this a way to do this with a version 4 pools of Uniswap?
Yeah, good question. So one thing you can do with hooks actually is make permissioned pools. So like make sure that only people who are like KYC'd or are on a certain list supply liquidity, or like make sure only certain people can swap on this pool. So I definitely think it's possible with like these lots of tokenized stocks that are coming out where you need to like have these specific permissions. So I think V4 is actually a really good place for it because you're able to like limit access to certain users.
Okay, thank you. And to follow up, so where these, let's say, tokenized stocks currently live, in what kind of pools do they currently live? Are version 2, version 3, version 4, or something different?
What do you mean, like, do tokenized stocks live in like V2, V3, or V4 of Uniswap?
Yeah.
I'm pretty sure they live in V4. Yeah.
Okay.
Yeah.
Okay. Thank you. Thank you.
Guys, any other question? Okay, well, then I will jump with one of mine. Oh, we have one from Stefanos. Okay, let's go first with Stefanos. He asks, what's the first thing you wish first-time hook creators understood before they launch on mainnet? Also, is the Foundation Security Fund still supporting new hook creators?
That's a good question. I think they are still supporting new hook creators, but I would have to double check. You probably have heard, but Uniswap Foundation and Uniswap Labs actually merged. So I would assume we're still doing it, but I would have to double check that. Yeah. And then one thing I wish first-time hook creators understood before they launch on mainnet. Let's see. I think a big thing would be like getting liquidity towards your hook. If like you really want people like to swap on your hook and like get routers routed to it. Because I know like a lot of routers will only like route to different pools that have a lot of liquidity in it. So I know like even though it might be like the best, or even though it might be like the best route or whatever, you still need a lot of TVL in that hook, like in that pool with that hook. So it is interesting, like to try to like get liquidity into your pool is tough. But it's obviously going to be needed in order for people to be able to swap on it.
Okay, I will drop mine. So I'm particularly interested what happens with respect to V4 hooks and MIV. Does it give us new ways to prevent it, or it opens new avenues for new extraction? Like, what is the state now?
Yeah, that's interesting. We're trying to like actually solve that currently with dynamic fee hooks, I think are really big. So like, because you can specifically like kind of get details on a specific swap, like if it's and like with oracles, you can also solve this problem too. So like if it's going away from a specific like reference price you think it's going to be, like maybe you know that it's an arbitrage, or like if it's going back, maybe it's like back run, sandwich. You kind of can like tell it also if it's at like the top of a block. So there's a lot of little details that you can try to see now, and it's still kind of guesswork, but you can adjust the fee based on that. So like maybe you want to charge arbitrageurs a higher fee, and that way LPs don't get robbed every time by the arbitrageurs. And so it's just, I think this dynamic fee mechanism is going to be really big to try to prevent that, in my opinion. But it is tough because you obviously, it's a lot of guesswork, but I think a lot of cool designs are out there now.
I see. I understand how the flash accounting can help you actually understand what will happen eventually in the contract and potentially spot arbitrageurs. But if you enter Uniswap singleton and then you use another contract and then you re-enter, the flash accounting stops when you exit, right? And you go to another contract, or you can have it like in an atomic swap and keep everything that happens if you go and use multiple contracts.
You could use multiple contracts, but it would all have to be in like one transaction. So like it's like the unlock on the pool manager, and then like you could go to any contract you want, but then at the end you still have to like lock it at the end, all in just one contract, all in one transaction.
Okay. Yeah. So the unlock happens always on the pool manager level and never on a specific pool. It happens on the pool manager.
Exactly.
Okay.
Yeah. Mm-hmm.
Great, thanks. And I have one more question. Okay, I understand the journey from V2 to V3 and now to the design space of V4. Like, what is the next day? I mean, we have now something much more efficient. We have fee reduction with the flash accounting and the storage, and we have V4 hooks where everyone can create custom logic in all these events that take place. What is the next day in designing AMMs, like the V5? If such a term exists, like what is the next step?
Okay, so we actually like, I'll be honest, we have not discussed like Uniswap v5 at all. And I think that's because we're just like so excited about Uniswap v4 still, because like v4 with hooks, you like can make all these AMMs because it's v4 is a platform basically. So I think we're just like still so excited about the design space for hooks, and we're trying to get like everybody to make hooks and like see what we can do with it. Yeah, so I think there's just like still a lot of design space with hooks. So like one, like I mentioned, would be like the dynamic fee hooks, which we're really excited about, to like try to maximize LP mark out as best as we can. So like adjusting based on if you're an arbitrager or not, and adjusting the dynamic fee, and adjusting like against like normal uninformed traders versus informed traders, and adjusting it that way to like help LPs the best that they can. And it's probably going to be different for like stable pairs where like two assets are very similar in price versus two assets that are like very different in price, like ETH USDC. So I think there's a lot of like different mechanisms. So it's not like one hook fits all. It's like it could be like very, very different for different ones. And I think there's also a really, really big design space now too for real world assets, like we mentioned. And because a lot of real world assets are becoming tokenized. So a lot of maybe like KYC stuff with that, just to try to get like more people on chain. And yeah, I think the design space is huge, like polymarket hook that we talked about, which I think a lot of people are like still thinking about how we can make that the best, like how we can make that work in a way. So I think there's a really big design space out there.
Thank you. And I have one last question. Since we have a lot of software engineers that are now kind of graduating from universities and they're actively seeking their Web3 careers, like how does it feel to be working for such a big protocol that has, you know, secured billions of dollars and have done trillions in trading volume? Like, how is this actually?
It's really cool, I have to admit. I actually got into crypto when I was also in college. And it's just really, I was in the crypto space for, I guess, 2 years before I started at Uniswap. So it was just really surreal to like get this job. And now like obviously just to like right when I started working at Uniswap to start working immediately on Uniswap v4. So it was just it's really surreal. And yeah, but I started in college too. I like studied computer science and math, and I was like really into security and cryptography. So, I mean, yeah, you're on like the right path for sure. So it's pretty cool.
Okay. Thank you very much. Guys, do you have any other questions now that we have you with us? Okay, we have a question from Wolfgang. Is AI agent integration via hooks something you look for? Is it possible to integrate agents in the swap?
Oh, that's an interesting question. I actually have not seen any hooks like this yet, but I have heard of the idea as well. So I feel like that's a really interesting design space that will probably happen soon, I would think. But yeah, I actually haven't looked at it yet, but it's definitely a very interesting use case, I think.
Thank you. Guys, any other question? Okay. So let's start wrapping up the session. First of all, again, Diana, thank you very much for this webinar. It helped us a lot understand a lot of stuff and what is the direction in the AMM design. Guys, for those of you that is the first time here in the webinars, you can join our Discord or see our webpage and get to know when the next actions we are taking. And the next Thursday at 7:30, we are hosting this event, which is global. It's a happy hour event at the center of Athens at SUIHub. And you're all invited. You can register and we can be there and talk. Diana, you're also invited, but I don't think you will come from New York to Athens next week.
I wish.
Yeah, I know. And okay, thank you again, Diana. And farewell. Anastasis, you can close the recording. Yes, good. Okay, thank you, Diana. Bye, everyone.